So now I'm going to try to define what type of suspension I'm going to have on this. And this is a procedure that I like to do in all my designs. I draw out the suspension geometry as a sketch before I start building in components and dropping them into the assembly. And it's a good way to figure out that geometry and the dimensions of everything really quickly. And so I'm just grabbing the dimensions from the shock models that I have to make sure I'm sketching everything correctly. And the critical distance here is the shock tube length and the distance from the bottom out plane to the pivot point. And what I want to do on this design is a push rod suspension. This is something that I always thought would be really cool, to have a set of shocks mounted inboard and then a push rod pivot arm right in the center of the vehicle. And so that's what I'm going for here. That's what this model represents. That vertical dotted line is the pivot point, and then those horizontal lines on top at those angles, that's the push rod pivot arms. And this geometry was a lot simpler than I thought it was going to be, primarily because there's just a lot of space back here to work with. Like the distance from that seat to the rear wheel is the full length of the engine. And there's a ton of room for both the coil carrier and the bypass shock, as well as the pivot arm and the push rod linkage. And since this is mid-travel, getting the shock lengths calculated was pretty straightforward. They both ended up being about 16-inch stroke shock tubes. So the next thing I need to drop into the assembly is the rear sway bar. And what I'm doing here is the sway bar is going to serve two functions. It's going to be the pivot point for the trailing arms, and it's also going to be a sway bar. So as one pivot arm moves, the other one will move as well because they're tied together with that sway bar. And it's an interesting way to configure suspension where the pivot point has all the anti-roll functionality.